Right, recording is rolling. Welcome to Friday. Oh, you guys just turned in your Momona homework. If you haven't yet, then just before you guys take off, but get you guys set with the lab here. You guys remember your momentum quiz is due Monday. Some of you guys have turned this in already, so if you haven't, then pick that up Monday. Today, get you guys set up with this lab, but first, let's take a look at what we're doing for the rest of the semester. So when you guys come back from the weekend, we're going to start the last topic before the midterm, which is going to be rotational dynamics. You guys seen a little bit of rotation stuff so far, so we're going to go back and do that. Right, then, we're going to get the whole week for Thanksgiving. So no school that entire week. Yeah, so then when you guys come back from that week, we'll finish rotational dynamics, probably take us just a couple more weeks, and then we'll go into midterm review and midterm. So that's what we're doing there. Right, so today, coefficient restitution lab. You might have a question like how bouncy is foam ball? I have lots of different ones. These bouncy balls are back. Somewhere where it bounces. There's some tennis balls back in the lab area. There's got a little ping pong ball. There's golf balls back there. There's even this guy. Here. Yeah, that bouncy one. So. What's the sort of a scientific physics way to couch this question? How bouncy is a ball? You'd say, what is the coefficient of restitution? Right, that's like a measure of bounciness between like some specified ball, say like one of these or one back there, and maybe like the tile floor, because it's really between two surfaces. Like even right here, you guys can already see, like that's not very bouncy here, but if I just shift this over, that's a lot bouncier right there, isn't it? Mark coefficient of restitution. Right, so. You guys have, or actually, here, let me remind you guys of the general principles. So there's this poster, I moved to the back of the room, so it's back there, you guys can look at it. Here's a very general way of saying coefficient restitution. It's how bouncy are two objects. So if two objects collide, what's the difference in their post-collision velocities after the collision versus before the collision? Okay? And then you just take the positive value of that. Okay? Now, if one of these objects is just the floor, then isn't it true that that object is just not moving, so it has zero velocity before and after? And if that's true, then wouldn't it just be the rebound speed compared to the drop speed, right? Would that be true? And if that's true, well, then you would have an equation that looks like this, right? Coefficient of restitution is what's the rebound speed compared to the drop speed? Actually, that's exactly the picture they have right here, right? You drop a ball, a boing, what's this rebound speed compared to this drop speed? Right? But then how do you figure out what those speeds are? Well, the only tool that I'm going to give you guys to measure with today is a meter stick. So, okay, I mean, you could measure these heights. What's the drop height and the rebound height? I mean, I bet it's related to that. Right? You guys might remember this from your notes too. So it's back in your notes. That do you remember going back to conservation of energy? That these speeds are each some like square root 2gh. Now you go through conservation of energy, you can show it, or even a kinematic motion back in the day. But the 2g part cancels out top and bottom. So this also ends up being just the square root of the ratio of the heights, rebound height to drop height, like that. You guys remember this? Okay. So you guys have a quarter page on your desk, and all you have to do is go with your friends, grab a meter stick, a ball, and complete this quarter page. There's a table on the front and a graph on the back, so let's look at this real fast. You guys got different trials, different drop heights. So try different drop heights, see what's the rebound height, take the ratio, and then, that ratio to the power of 1/2. You guys, what is power 1/2? What's that equivalent to?
Square root.
Square root. Hey, just like that, square root. Okay. Then on the back, I have a graph space for you. It says drop height versus rebound height. So, rebound height versus drop height. So here's your rebound height, little h. You could do it like centimeters. Here's your drop height, capital H. It could also be centimeters. What do you think that graph's going to look like? So you put like 0, 0 right here. What's that graph going to look like? For different drop heights, there's going to be some rebound height. It's going to be a straight line. It's going to be kind of curvy. And then you can make an equation based on that. So see if you guys remember that this coefficient of restitution is bounded between two numbers. So like see this one right here? What's the coefficient of restitution of what you just saw? Well, how about this? What's its rebound speed of? That would just be 0, right? Right. Okay, so 0 divided by anything, that would just be 0. Right. What's the maximum that this coefficient restitution could be? Maybe the rebound speed could approach the crash speed. So this could maybe sort of approach 1, like go up to 1. Right. Okay, so that's just a reminder of some boundary conditions on that. Right, so just complete that quarter page with your teammates. Pop that in the grade tray for the end of class, and that's all we got.